If you're working with Kubernetes architecture, you know how hard it is to manage your microservices within the Kubernetes namespace. With service meshes, it's easy for you to manage your microservices deployment within the same cluster and also across the clusters. In some of my earlier videos, you would have seen different service meshes like Linkerd and also the architecture for Istio. In this particular video, we are going to look at the Istio deployment within the EKS cluster. We are going to see the hands-on part on how to do Istio installation within an EKS cluster and also deploy a small application which is provided as a part of the Istio documentation in order to understand the different flows and identifying the flows and looking at these flows using different observability tools and tracking tool. With that, let's get started.
Press the bell icon on the YouTube app and never miss any update from Tech Primers.
In the current video, I'm going to use Istio 1.9, specifically 1.9.2. So if you're following it now, you can use the same link and then just follow the video. So the first thing I'm going to need is the Istio installation or the Istio CTL installation and things like that. So the first step necessary in order to get started is downloading Istio. You can follow this particular command, curl download Istio. I just downloaded the same Istio version. It takes a while, that's why I triggered it a few minutes ago, and then it got downloaded. And now I can do the configuration check. So I'll set the path so that my Istio CLI works with the same version. I'm going to do a pre-check. So there is nothing configured right now, that's why it is showing like that. I'll also say Istio CTL version just to check the version of Istio. Right now the master environment is not configured, so what we are going to do is we are going to create the Kubernetes cluster within the whole EKS space. So let me go to the AWS console and I'll show you where I'm going to create it. So I'm clicking on Elastic Kubernetes Service within the AWS console, and I'll be using the region US East 1, which is North Virginia. I can go to the clusters and then I can show you there are no clusters right now. I'm going to create a new cluster. To create the EKS cluster, I'm going to leverage the EKS CTL command. So I'll be creating using this particular command, EKS CTL create cluster, and the region which I'm using is US East 1. I also want to reduce the number of nodes, so I'm going to leverage only 2 different nodes because I have already selected M5 large as the type of Istio instance which are already large. So I can leverage the same, and I have just triggered the command. So let's wait for the cluster to be created. Let me open a new tab below so that I don't disturb the existing cluster creation shell. So let me go to the shell and then I'll just say horizontally. So this is going to create a new shell for me, and let's go to the version Istio 1.9.2. So I'm inside the folder. That's what this documentation says. So we need to go into Istio 1.9.2, which we downloaded as a part of the curl command. Once we are inside, there are different directories. Sample directory denotes we have some sample application which we are going to deploy, and also we have some Istio client library, which is the bin, right? So we need to set the path for that as well. So let me set it here, and then we are sorted. So once that's done, we need to install Istio in the Kubernetes cluster. So right now our cluster is getting created. Let's wait for the cluster creation to complete, and then we will trigger the Istio installation command. So meanwhile, I'll just copy the command. What we are going to do, we are going to install Istio, and then we are going to set the profile as demo. All right, so that's what we are doing here, and also -y denotes installation yes for all the prompts. So let me wait until this particular cluster gets created, and then I'll try to run the whole Istio installation. So the cluster creation got completed right now. I can see that message here. So let's look at the nodes by doing the kubectl get nodes. So this is returning the 2 nodes which we just created. Right now the EKS cluster is using 1.18.9 version of Kubernetes. So I think we are all ready. I'll just do a kubectl get all -m default. So right now there are no pods running in this particular cluster. I just want to check that. So yeah, there is nothing running right now. It's just the default cluster IP service which is there, which is configured under the default namespace. Just to be clear, I want to mention, or I want to look at the different pods which are across the namespace. So that way I want you to show what is currently running and what we are going to add. There are two different kube proxies, two different AWS node services, and then there is core DNS. So all these are running on our individual nodes which we have configured. We can't see the control plane because AWS manages that. Now with that, let's install Istio. So as a part of the installation, you should be able to see different pods which get installed as a part of the Istio-system namespace, which I'll show you in a bit. So I have triggered the Istio installation command. So we should be able to see Istio pods getting installed in this. Meanwhile, let me keep the documentation ready. Yep. So what's the next command? So the next command is to inject Istio into the namespace. So I can directly do that, or I don't have to inject Istio. Instead, I can deploy my application and then inject it. So labels are basically a kind of configurations using which your systems can behave. So Istio looks at a particular namespace and then checks if that particular namespace is eligible for installing or configuring Istio or not. So for namespaces, you can configure Istio. So you can control your boundary at the namespace level. So I'm going to apply the kubectl label namespace for my default namespace because I'm going to apply my application within the default namespace. If I want to specifically do for a particular namespace, I can provide that, right? And then you have to provide this particular flag which says Istio-injection equal to enabled. So based on this flag, my Istio sidecars and stuff like that will be installed as a part of my application installation. So let me go back. So Istio installation is complete. Let's look at what's happening within my cluster. Now you can see that there are three different services which have got introduced now compared to the earlier one. They are all present in the namespace called Istio-system. So this is a new namespace which Istio creates, right? And one is the egress proxy, the ingress gateway, and also the Istioid. Now if you remember the architecture diagram which I showed in the architecture video, let me show that. So this is the architecture diagram which I had shown, right? So the data plane is nothing but the sidecar container which will be sitting along with the application within the same pod, right? And that's what Envoy is all about, the data plane. And control plane is where we will be storing. So this is the Istioid, right? So Istioid is the is this particular part, right? So this is the monolithic application which Istio uses. Earlier Istio used to use microservices deployment, but then they just merged Pilot, Galley, and Citadel into one, which is Istioid, right? So this is the whole control plane versus data plane, right? So this is already set up. Now when we deploy our application, we will have one more sidecar sitting with our application, and using that sidecar, my control plane will speak to my application, right? So that's how the Istio service mesh works. Now that my Istio processes or pods are running, I have my incoming connection and outgoing connection ready, and also I have my Istioid for doing the configurations. So let me go back to the documentation and then deploy the sample. So I'll just copy this command so that I can directly deploy the sample application. So let me deploy that here, right? Since we are already here in this folder, we already have samples folder. Yeah, so I think we should be good. So I'm just using the kubectl apply-f and then giving this bookinfo.yaml. So this bookinfo.yaml is going to create multiple services, multiple service accounts, deployments, rating services. So we will look at what are these microservices in a bit, but it's just deployed already. So let's look at what's happening in the pods. So if you see here in the default namespace, there are different applications which are getting created. So for example, there is one microservice called details, which is v1, product page, which is v1, ratings page, which is v1, and then there are three different microservices which are reviews, v1, v2, and v3. So these are three different versions of the same application which got deployed. So let's wait for the application to finish running. So I think it's already running, right? So we are good here. So the application which we deployed is already running. Notice that right now it has only one container. So it just says 1/1, right? That basically means I don't have any sidecar which is running within the application, which can take care of some additional service mesh stuff, right? So it's just 1/1. So only my application is running, nothing else. Coming back to the documentation, so that's what it's mentioned, right? So the next step is to get the details of the service. So what we can do is we can go to kubectl get service. So this will show what are the different services which are created. All my services are cluster IP. That basically means I cannot access these services from outside the cluster. So within the cluster, if somebody assigns a cluster IP, only the components within the cluster will be able to resolve this IP address, because this is specific to a Kubernetes cluster, right? So all my microservices details, product page, ratings and reviews, they all have been assigned to this particular cluster IP, and they have different port mappings. Coming back to the documentation, we already confirmed that we have a pod, but if you notice, all my containers are having 2/2. This is because we did not apply our label within our cluster. So I just wanted to show you without applying the label, and then I will apply the label right now, right? So if you see the number of pods, if I do kubectl get pod, this will show that my application is just deployed, but then how will I access this, right? I mean, right now there is no way for me to access because all my services are cluster IP, right? From my external cluster, I cannot access this application. So this is because I wanted to show you how Istio works. So if I miss this particular command where I'm just injecting Istio here, then all my applications will not have my sidecar deployed. So this is right now just showing 1/1. Now if I show you here, right, still it is showing 1.1. So now how do I re-trigger, right? One thing is to delete everything and recreate, or I can do kubectl delete pod, and I will delete, let me show you by deleting one particular pod. So if I delete this particular pod, this pod is going to be recreated. When it gets recreated, my Istio is going to be added here. So the data plane is injected here. So notice that I deleted the details pod. Now it is up and running with 2 containers within the same pod. So this is the envoy container which we saw in this particular diagram. So this is what it is, right? Now I'm going to delete all these pods as well so that it can create in a full-fledged manner. So let me do that. So all my pods are deleted and I can see all my statuses are running here. So let me do clear. So that's it. So we have details v1, we have product page v1, we have ratings v1, we have reviews v1, we have reviews v2 and v3. So let me clear it. Going back to the documentation, our deployment step is completed. In order to verify if our application is working, there is a step here using which you can hit the endpoint within the pod for the rating service. So if you look at this, this is the command for it. So let me copy this command and then I will execute it and then I'll tell you what it does. So we got the response as simple bookstore app, which is what is expected. That basically means our application is running. So kubectl get pod label and then app equal to ratings. What's happening here is we are retrieving the pod name and then we are logging into that particular pod using kubectl exec. So kubectl exec command logs into that particular pod. So we're getting the pod name by this using the metadata using JSON path, and then we are passing that as a parameter to the kubectl exec, and then we are going specifically to the ratings container and doing a curl from that particular container on the products page, and then we are grepping only the title of that particular response. So if I don't grep this, it will display all the message here, but I wanted to just get the title so that we know we are in the right path, right? So that's what this example explains. So we are good here. So we logged into a container, we did a curl, and then we are able to see what's happening. Now the next thing is, how do I access this particular application from outside, right? We did not do anything fancy. We just applied our application. We don't have any ingress setup. It's all just pods, right? I mean, I have just deployed my application, but how do I access this particular application from the external world? That's where the gateways are helpful, right? So here the next command says apply the sample for the book info gateway. So let's apply this. Meanwhile, what I will do is I will look at what's the file like. So let me open the book info networking. So if you look at it, there is a new CRD called gateway, right? So this is a custom CRD. So CRDs are basically custom resource definitions which are created by individual components or frameworks and things like that. So here Istio is a component, new component, right? So they have created their own custom resource definition which is called as gateway, right? And then the API version is configured based on this particular whatever version we provide here. So the name of my gateway is called book info gateway, and it's allowing my incoming traffic. So ingress gateway. So ingress gateway is nothing but the incoming traffic. So my book info gateway is going to allow my incoming traffic on port number 80 using HTTP traffic, and it's allowing every host to access my application. So that's the full gateway piece, right? So the gateway is just the API gateway kind of a configuration where we just allow the incoming traffic from any host. So you can restrict those in the host section here. The next one which we are applying here is the virtual service. Virtual service is another new custom resource definition from Istio, using which you can specifically match whatever gateways you are getting in, right? So you can match the HTTP URL and then you can add those with the corresponding gateway service. So this is similar to an API gateway. The virtual service is like a gateway which can route traffic by matching it with a specific pattern, and then it just redirects it to the gateway service, and then specifically based on the host as well. So that's what this does. So see that all my URL prefix which match, they are getting redirected to my product page which is running on 9080 port. So this particular port number is my service port number. When I did a kubectl get service, I could see that the product page has 9080 port. So my product page has 9080 port, and that's what we are defining here. So we are creating two things. One is the virtual service and also the book info gateway. Now how do I look at those details, right? So I can do kubectl get gateway. So kubectl get gateway will show me my book info gateway. I also can do kubectl get virtual service. I can do a VS, which is a short form. So it just shows that book info is the name of the virtual service. It redirects to the gateway, book info gateway, right? And it allows all my hosts to go into that. So we need virtual service and gateway in order to get our traffic into the Kubernetes cluster via Istio. So these two are specific to Istio. So let me go back to the documentation. So the next command in the documentation is Istio Analyze. So Istio Analyze is going to check if there is any issue in terms of accessing your application. So let's apply that and then we can talk about it. So that was quick. So the Istio Analyze got completed with no validation issues. So this identifies if there are any misconfigurations within the cluster, which we can identify now itself. That's what Istio Analyze does. The next one is identifying the ingress IP address and the port number. So in general, how do we identify is you can directly use the service from the Istio system. So let me leverage this and then we can see. Let me do a clear. So I can see that there is a URL here which is coming from here, right? I mean from the external IP. Since I'm using EKS, this is going to be my ELB, which is Elastic Load Balancer. So let me go to the AWS console. Earlier I think we did not even see that the cluster got created. See that? So I have my cluster already there. So let me go to ELB, right? So ELB is Elastic Load Balancer. Let me go to EC2 and then there is a load balancing option there. So I can see two instances of my EC2 running, and then I can go to load balancers. In the load balancers tab, there will be a new load balancer. This is the load balancer which got created right now, right? Which is getting used for my application here, right? Coming back to the documentation, I can see that we need to set some variables. So these are like good to have. If I set these variables, I can easily get my ingress host name and port number, whatever we just configured. So let me get the port number from there because I was not able to identify. So let's do all these. So all my variables are set. Let me do an echo dollar. So we do have our variables set. I think we are good here. So let me go back to the documentation. So we have all these set. So the next one is getting the gateway URL, because all these commands are specific to cloud platforms. We are already set, right? I mean, we have the ingress host, we have all those things ready. So the next thing is setting up the gateway URL. So gateway URL is just a combination of the host name and the port number. So let me set that. I'll do a dollar gateway URL just to validate what is the gateway URL. Looks like the ingress host is not set. Now in order to get the ingress host is nothing but our ELB URL. So previously we did a command to identify the ELB URL. Let me get that command. This is port. Yeah. So using the get service of Istio ingress gateway, we got the external IP. So this is nothing but the ELB. So this is going to be our ingress gateway. So I am going to just set the variable which is ingress host as this particular host name. Now I'm going to also set my gateway URL with the ingress host and the ingress port. That way I can now do a echo on my gateway URL and then we are sorted. So based on documentation, the next command is accessing the application using that particular gateway URL. So we are going to do an echo like this and then get the output and then hit it in the browser. So I'm going to copy this HTTP URL, go to the browser, hit it. We should be able to see our product page. Awesome. So we are able to see now the product page. See that there is a review rating here, which is something. If I refresh again, so see that the color is different. This is because these are different versions. See that it's gone again. So these are different versions of my microservice. If you remember, there were like different reviews, v1, v2, v3. So that's what this denotes. So I'm just accessing the application. Let me refresh it multiple times to see and create some artificial traffic. Awesome. So looks like it's good. So this is how you can leverage Istio. Right now we didn't look at any of the configurations, but we just deployed the product page. Now how do I understand what's happening underneath, right? That's where we can look at the dashboard. So Istio provides Kiali add-ons. So I'm going to install the same so that we can look at a high level how my flows are going in, right? So we are going to look at how we can leverage Kiali for that. So I'm going to install the Kiali plugin. So there is a kubectl apply sample add-ons. So I'm going to use the same and I'm going to apply it from this folder. So this is rolling out my Kiali deployment. So Kiali is going to create Grafana. See that it's getting created, and then the Grafana dashboards are also getting created. It also did something. It also integrated Jaeger. Jaeger is a distributed tracing platform or a tool using which you can understand the logs which are traced across microservices. So when I installed Kiali, I also had Jaeger installed because I have all those as add-ons under the samples here, right? So that's the whole deployment. So everything got created successfully, right? What's next? So how do I access my Kiali dashboard, right? So this is how you can access your Kiali dashboard. You can just do istioctl dashboard Kiali. This will open the Kiali dashboard in the browser, right? So see that it automatically opened localhost and then it's just logging in. So let me reduce the size. So this is a UI using which you can understand what's happening within your cluster. So see that I have my default namespace which has like one particular label which is Istio injected. There are 4 applications. If I click on it, I can see the application names. If I want to look at the flow, there is an awesome page where it just mentions graph, right? So I can look at the graph of what's happening. So right now I don't have any traffic, so I'll just generate some traffic because I installed Kiali just now. So let me add some traffic. See that it got refreshed quickly, right? I mean, so this is the microservices deployment. So we have one particular microservice called products page, and which is, hold on, let me show you. So this is the one. The products page is the major UI, and then there is details, there is ratings, and then there is reviews, right? So if you look at it, products page connects to details, right? And that's v1. Again, products also connects to reviews. Reviews has three different versions, right? v1, v2, and v3. v1 doesn't connect to ratings, but v2 and v3 they connect to ratings, right? And then they are differentiated based on the color, right? If you had seen in the review rating, there were some red and then there was some black, right? That's the different version which they have deployed. So this is how you can identify your flows, right, with Kiali. What if I kill something, right? I mean, just for fun, what I'm going to do is I'm going to just delete a pod and then access my application. So what happens to my application? So see that there was an error fetching the products. It did not fail for the whole page, but only that particular section failed, right? Now if I refresh, I got my book details, right? Now in Kiali, notice that there is a red option here. So this is because one of my flow failed and I'm able to see that now. So I just artificially generated that failure, but you can do it. See, now it's green because all my subsequent calls are successful, right? So this is how you can look at the flow of your circuit breakers which got triggered, and then we could see at a high level with Kiali all those flow, like what Istio's dashboard used to provide. This also shows the success rate, the outgoing success rate, total, all those things can be viewed here. We can also look at the workloads which we deployed and the services from here. So we don't have to like type in kubectl commands, and we can see that from here directly. Specifically for Istio, you can look at what are the different configurations and what are the different CRDs which you have configured. So see here, we have configured two different CRDs. One is the gateway and the other one is the virtual server. So both these are getting displayed here. The one thing I liked about Kiali is the graph, which helps us in identifying the flow, right? So that's the major advantage of using Kiali. So let me refresh again. I should be able to see my graph. So I'll refresh again and again, and then I can see that here. And you can also see that the incoming traffic is coming via the Istio ingress gateway, which we had configured, and that is all integrated with the ELB within AWS, which can be seen in the EC2 instance. And this is where the load balancer is present, right? This is specific to us. Let me go back to the documentation. So what else next, right? Once Kiali is done, we also had installed Jaeger, right? So in order to look at the Jaeger dashboard, I can use Istio CTL dashboard Jaeger. Sorry. So this will open the Jaeger dashboard. So Jaeger, if you don't know what is Jaeger, Jaeger is a distributed tracing platform using which you can trace requests across microservices. So let's say I select my product page as my service here, and let me do a search. You can look at or search by trace IDs, or you can look at request at an individual request level. So if you see here, if I select that particular request, there was a request which came in from the Istio ingress gateway. From there it went to the product page microservice, right? From the product page it went to details, and also it came back, and then it also went to reviews, and from reviews it went to ratings, right? So these are multiple microservices, and you can see how much time individual requests took in each of these microservices, and all these are like glued together, right, in the same UI. We saw the similar kind of thing in Kiali right here in this graph, but Jaeger does at the log level, right? I mean, these are like request level. You can look at logs, you can trace requests based on the trace ID, right? Because based on the request it generates a unique identifier, and using that unique identifier you can trace your request, right? So that's how Jaeger does it. I don't think I made any specific video on Jaeger, but it's a good topic to have. Let me know if you guys want to see any specific topics on Jaeger, this particular UI. I can definitely try configuring it. But this is a very useful tool, similar to what we do with Spring Cloud Sleuth. This Jaeger UI provides a UI as well, and then it just stitches your request and then identifies your trace ID, and then we can get all these in one particular UI. Jaeger is a product from Uber, and it was open sourced. So yeah, that's that. So with that, we have reached the end of the demo. So I'll just summarize what we just discussed and what we just did. Initially, we created the EKS cluster using the EKS create cluster command. Later, we installed Istio within that particular cluster. Once the Istio was installed, we deployed our application within the Istio cluster. Later, I applied my label so that the deployments can get triggered by Istio, so that we can have the data planes which can get installed, the envoys, right? Once they were installed, we were able to see the request getting successful. We configured, or we understood the ALB URL, and then we hit our product page directly. Using Kiali, we were able to look at the graph with end-to-end view on how your requests are going through. And using Jaeger, we were able to trace our request across microservices at the trace ID level. These are not the only features which Istio provides. Istio provides more than these. It also has capabilities for circuit breakers and stuff like that, which I have not shown here or which is not there in this particular demo. However, if you guys are interested, do give it a try. And then there are different documentation and separate guides on how you can configure and try each of these individual features from Istio. So in the end, you can also see the next steps. In the next steps, you can see the different features which Istio provides in terms of fault injection, traffic shifting, query metrics, visualization metrics, etc. Right? Try each one of them and then let me know if you want me to try any specific topic within Istio. I hope you were able to understand how Istio works and how it does magically so many things, and it makes your life simple by deploying different microservices within your Kubernetes cluster. As always, if you like the video, go ahead and like it. Meet you again in the next video. Thank you very much.